tyFlow Basics Script Operator Part 3 Practical Example. Enjoy. Alright, so in this Part 3 we're going to try and make this animation. Now this might look similar to some custom properties tutorials out there, except that one of the things you'll notice is way more mechanical. Like, it's a very defined movement in all of the particles height position data, and that's because of what we've written in our script. Now this is going to be a combination of script and tyFlow working together to create this. We will have to cover a couple of other topics to explain this flow, and we'll do them before we go through the tutorial portion of it, but we'll explain what's going on here, and I'll cover things like global variables, custom methods, etc., and then we'll get into the creation of the project and explain it. So let's talk scope and what does it mean. Scope is the visibility, right? So, and visibility basically equals accessibility, right? So if a variable isn't visible to the method or the action that you're writing in script, its data won't be accessible. So you can kind of think of scope being either global or local. And global just means that for most part it's accessible to all of your script or all of your application, and local means it's limited in access to only certain parts of the program within that local range. So how do we explain that so everybody can understand it? Well, if we think Tyson has some methods that we use to write script in, public void simulation start step is the one we're going to use, right? And then we do our little curly brackets here defining the end. Now if I define a variable outside of this public void simulation step, so say I define an integer, right? Integer my int equals 9, right? So that's a variable that's been defined outside of all the tyFlow methods, so it would be visible inside here. So for example, I could use just delete that one there, my int, and I can now say it equals 10, for example. So because I defined it out here, this variable has a scope, that covers this whole anything in tyFlow. We're only looking at my simulation step, but if we had my simulation start and all that, that would be part of its scope. So the variable is accessible in that whole range. Now if I define a variable in here, so I now say integer my integer b equals 0, right? This only has scope inside of the public void simulation step. And so I hope that helps explain. So this would be kind of like a local scope, right? And down later on in code here, for example, I could do my integer and b equals 15. But if I tried that out here, I would get an error because it doesn't know about the variable. So I hope that at least gives you an idea of what scope is, but there's plenty of information out there on the web. Just Google scope C+, and you will find all the info if I didn't do a good enough job explaining it. Now, why did I start off by mentioning scope? Because we use it to great effect in our scripting, and if we kind of look at the script file for this example project, the first thing you'll notice is I got some variables that are defined up here at the very beginning, and then I got some custom methods. There's one, and here's another, and here's another, and you notice they've all been defined outside of the public void my simulation step, and we're not using the other ones here. So if we go back in here for a minute and delete that, and delete that and get rid of that, so we can write, and we go back up here for a minute. Because I've defined these variables up here, they're essentially global because they're outside. So that means now I can do something like, we'll explain this after, so don't worry about it. I can define like, what frame skipping do I want? And then I can have my random numbers and my minimum and maximum here, right? And now these variables are accessible all throughout the application, so I can use them to initialize stuff I want and then easily use them throughout the application. So when we scroll down here, for example, we can see that I've used the minimum and maximum that was defined globally right here, right? So, and then I use them again down here. So rather than having to keep remember what my minimum and maximum was and keep retyping it, and then later on if I want to change it, then I got to remember all the places I put it. So by making those particular variables accessible globally, now I only have to put them in one spot and I can update or change them if I wanted. For example, if I wanted a bigger random maximum instead of what I've got, I would just change it up there and it would now be used throughout the application. So I suppose now that I've talked about custom methods, even though I did touch on them earlier, we better explain them a little bit more in detail before we move on to the coding of our example. Seeing as we're using custom methods in this script for this tutorial quite a bit, we need to go into it a bit further in depth than we did earlier. So over here we have 3 examples of some custom methods I've created. And again, method, function, similar result, right? It's a way of organizing and putting code into little reusable segments, right, or sections. So in this top one here we say public, so that just means it's accessible to all. It's not going to have any return, so it's void, and this is the name of my custom method. And then in here we would say do something, right? We would have some code. So if I was, so this is like a little section of reusable code. So in tyFlow or in the script, when I want to use that, whatever this is going to do, to use it, I would just say my cust meth, and like that, and like that. And now we would be calling this custom method here, and it would do whatever was in line here. So for example, we could have a whole heap of code that prints out a whole heap of debugging. information, and every time we want to print that debugging, we would call that custom method or function. In the second example here, alright, it's a public method or function, and in tyFlow they're all going to be public. And it's another accessibility issue, but for the scope of tyFlow tutorials, everything's public. We're going to return an integer here, and this is the name of our custom method. So in our script code, wherever we're going to use this, we have to be ready to accept an integer for return. So we could say integer. Alright, I'll just give it a different color. Integer my int. Alright, and then we would equals, and we would just say here my custom return, and we need to have that and then that. So this line of code here is now going to reference this custom method, and whatever it is we do in here, it's going to return an integer. So we are returning at the bottom of this method, we use the statement return, and it says I return an integer, right, that we here set to be 10. So when we come over here, when we call this function right now, it's not a very great example, but it's a fully valid example, right? It's going to put 10 into this integer here in my main code, and I can use that whenever I want. Now down here in example 3, right, we have where we return a type integer, and we have two parameters in our method, and they accept type integer. So for example, in our main code, to call that, we're going to accept an integer and return, right? And we can say here let's give it another color. My add integer equals, and now we want to call that my custom add, my custom add. It needs two parameters of type integer. Alright, so we could say 10 and 5. Alright, as long as they're of type integer, because that's what it expects. Now whenever this function is called, it's going to return that number into my add integer, and right now it's saying over here in our example code that we're going to add two numbers and return the result. So in this case, when we call this function here over here, right, the return would be 10 plus 5, and it would actually return 15, right? So my add integer would end up containing the number, it'd be alright if I could spell, would contain 15, right? That would be what ends up being there, with this not really being code, but just an explanation that the result of calling this custom method over here was to add two numbers, and it's going to return an integer, and that would be the result that we would end up in this value here. So there are three examples of custom methods, and we're going to use custom methods in this tutorial, and it makes it easy to repeatedly call the same thing and not writing the code over and over and over again. And let's go look at how we actually did that in practice. Alright, let's get rid of this for a minute. And alright, so we're in tyFlow, and you can see here, I'll explain all this code before the end of this tutorial, but right from here to here, this is a custom method, and I am using it over and over again in the program. At the moment I've set frame skipping to 20, which I'll also explain after. So every 20 frames at some point these custom methods are going to get called. So you can see I'm not going to return any type, but I'm going to call this function called getRandomStart, and long story short, it's going to end up putting a start position into a custom float, and we'll update it every now and then. We delete that here, scroll down a bit further, and you see the second custom method here, alright, is getting the random end position of all our particles, alright, and then another custom method here that is going to transfer the end position to be the new start position of the next sequence. And we'll delete that and scroll down a bit further here, and you can now see here that we're in the section of code here that's going to happen on each simulation step, right? So that'll happen each frame, right? This whole check. And you can see here that I'm doing a test, but more importantly, because we're going to go over this stuff, is you can see here that I'm calling these custom methods. So each time it's on frame 0, it's going to go here. Each time it meets my frame skipping method, we're going to call these, and we're going to do that repeatedly, right? So that's an example of how we organize our code into little snippets, things that we're going to repeat over and over, we put into custom methods. So with that being said, let's take a look at our flow, what we're doing, and then we'll explain the code involved. Let's go through this flow. Now my goal here is not to sit here and do every single step in front of you, because I think that's where tutorials fail. You should be able to do your own stuff, but we'll go through everything here, and then hopefully with that knowledge you get creative and make your own stuff. But this is the flow as part of as far as the tyFlow portion of it outside of the script. So we just birth an object which is just a plane, right? X whatever number of grid size you want it. I think mine was something like 64 by 64 plane grid, and we do 3 custom properties. This one here is just a placeholder. It's set to only happen on event entry, and it's just a placeholder for the start position, which is, you know, we give our particles a height from the very beginning in script, and then we also have an end position, because what we're going to do through scripting is we're going to animate the particle from the start to the end and then cycle that continuously. And this custom properties here is for the coloring of the particles. Let me just do that, and we scroll forward one because I initiate everything after frame 1, and this is what gives us the coloring, this custom properties here. And the face fracture here just splits each polygon in the plane into its own particle. We scale it a bit smaller so that we get some gaps, and we give it the shell, which is what gives it the height. And then of course we got our script here, which will actually be what assigns the target start and end position. And this custom properties here is basically, rather than do it in scripting, it was easier, like once we've gotten random height and random start and end, then we just use this to animate the height. And we're using the data from up here for the coloring, and we have a ramp in our materials, These three here are just for debugging purposes. But so from that perspective, it's a pretty simple flow. And just to visualize how that looks for a minute, get rid of that, and we turn all these off for a minute. And you can see here we birth a plane, basically a fairly simple plane. Once we face fracture it, each one of these polys becomes a particle, and you can see the number here increases 625, and then we scale it a bit smaller because I wanted some gaps between it. Then we give it the shell, which actually gives it that three-dimensional height, right? So we've given it some height there, you can see there, and with the shell. And now we're going to do our script, and let's go through this script in detail. You can see as soon as I turned on the script, we actually gave it our initial position, and then we map. And but let's go through everything in code and explain it right down, and even how I came up with the idea and how you might progress with your very own idea, and where you would get the help you need to bring your idea to fruition. So we know from our statement earlier that tyFlow is going to be a script kind of thing, is going to be a combination of tyFlow events and operators as well as the script. So that means we're going to need some sort of tyFlow API, and we're also going to need some C++. So if you're not a hard coder, like a hardcore coder, how do you get help to get this next step? Well, generally speaking, what you want to do is, if you're going to do something like let's say you want to do a loop, right? Well, the way that you would find help on looping, which is not tyFlow, you would do C+ loops, right? And then from that, you can now go here and get all the various types of loops, and then get examples. So this would be if you know you need to loop through a particle, and that's kind of C++, and it's not explained anywhere. And then you can, for example, do C+ variables, right? Variable types. And then you could, for example, come here and you get examples. So this would be, if you're not proficient coder, then the method that you want to find your information is C++. That's what interacts with tyFlow script, and then search for the kind of thing that you need help with, right? For example, C++, modulus, you know, and this is kind of where we use it, like the remainder. For example, if we want to do frame stripping and we want to know if a number is exactly divisible by, for example, if I want to skip every 20 frames, then I would use the modulus operator and test for if it's even divisible, say for example by 20 for 20 frames. Is it even divisible by? So how would I get that information? You could even do something like C++ evenly, I think, divisible by. Alright, find out whether the number is divisible by 2. So there you get, and there's an example. But this is how you would find that information. So I hope you find that helpful in trying to find your own information for something you're totally trying to create on your own. Okay, so let's really explain this script here and how all of this came together what it does, and how this combination of tyFlow operators and script produces this result. Alright, so how do we do it? Big question. Well, we'll use a custom properties operator to hold script data, and that's going to be the position start and the position end of our particles as they animate up and down. So one custom property operator will hold the end position, another will hold the start, will animate between the two. Now, in the life cycle of this animation, at some point we need to transition the end data to the start data so that, you know, for the next 20 frames or whatever we decide the frame skip to be, alright, we don't just assign a new start position and we get a jerk because it doesn't match up with the old end. So let's say that we animate to here and that's the end. Well, that should be the next start position, and then its new height is where it travels to, so you get a smooth animation, right? So if we kind of look at the idea, we need to initialize the start position of our particles. It will be a random height, right? So for that we're going to need some sort of C+ random method, alright? Then we also want a random new position that the particles will move to. Well, for that we're going to need another C+ random method. We want to control the speed of the animation. Each frame is too quick. So in other words, if we update the particle height every single frame, it's going to be way too quick, right? It'll just going to be like the cubes are going, right? So we need to slow that down. And how might we do that? Well, one way would be to only update the position every X amount of frames, and you can play around, determine whether it should be 20, 30, 40, whatever it is you want to look. So for that we need some way of being able to skip frames. Now the way that I came up with being able to skip frames is there's a C+ method that says, is a number, in our case a frame number, evenly divisible by another number? If so, the test condition will be true. So in other words, if I want my animation to only update every 20 frames, is the frame count evenly divisible by 20? If so, do the next update. So for that we need some sort of evenly divisible by, in which case this is like, they call it the modulus operator, but it just means, is there anything remaining? If I divide 10 by 3, is there something remaining? In this case there would be, 1 would be remaining, in which case 10 is not evenly divisible by 3, if you get the idea. If we were on frame 9 and I do a test, is it evenly divisible by 3? The answer would be yes, because 3 goes into 9. So from this C+ side of things, we're going to need to be able to do this whole animation. We're going to need to do a little bit about loops, because we're going to have to animate through all the particles. We're going to need variables to hold data. We need random number generators. We need to be able to skip frames, and the easiest way to do it is to use some custom methods, because we're going to be repeating a lot of stuff many times, so we don't want to rewrite the code. From the tyFlow side, right, we need access to custom float data. We need to cycle through particles. We need to adjust the height of the tyFlow data. We need to be able to write to the custom float, and we're also going to do some color ramping. Now, one of the problems over here would be, well, when we have a start position and then an end position, how are we going to move from start to end? We could do it in code, but I just took a good look at it and thought, well, it's probably easier just to do it with a custom properties get operator, and then to adjust the time, like say we set our frame skipping to be 20, then we just adjust the interpolation until all the movement stops just before that 20th frame, so they're not still in the middle of moving while we update to the next position, because then we would also get jerky. So once we've decided on a frame skip number, then we play with this interpolation here until we get a nice smooth animation. And if at some point we decide to adjust the frame skipping, let's say we want 30, we think it looks better than 20, then we would have to readjust the interpolation. And that's the way that I decided to do this. So let's get into the script and break it down. Let's get rid of this for a minute. And come in here to our script operator. And let's look here. Alright, so we're going to define some global variables so that they're accessible anywhere inside the script. And I've created 5 of them. One is our frame skip number here, alright, and the other is the random number, just to initialize it, right, a placeholder for the random numbers. And then what is our random minimum and what is our random maximum, and this translates into what height are we going to have the particles travel to, right? So in this case, the maximum height for our distance is going to be 26. So let's look at our first custom method, right? And that's this whole block of code here. And so if we're looking at this block of code here, I've created a custom method that I called getRandomStart. Now I've over-commented this script so that you can easily see everything I've done with more explanation that I would generally put for myself. This extra commenting here is to try and you can pause the video and get a better explanation. But what we're doing here is I looked up how to create a random number in C++, and so I'm creating a random number variable, and I'm going to do a new random number. Now because I didn't want my start to change each time for the very first initialization, I've put a fixed, this 5 number in here actually means seed, right? And so what that'll do is by stipulating the 5th seed, I'm going to get the same result each time here. Then we create a loop, and we're going to step through each particle because we need to update each particle's position. So what we're saying here is for integer equals 0, I, if I is smaller than however many particles are in the system, in the flow, keep going through all the particles, indexing by 1 until we reach the end, right? And if that's the case, do this block of code. So we're going to do all this code. It'll just happen seamlessly, we won't see it, for each particle. Now what I'm going to do now is each particle has to have its own random. So this random start, here's our variable here. This is a way that we get the next random number is you use the dot operator and you access the next part of the random function, and we're saying give us a new random number between our minimum and maximum, and that was what we had the global variables up there. And to get the simulation index, sometimes we don't want to hard code the particle ID. We want to get it from the number and make sure we don't get any errors, because maybe the simulation index could somehow be different to a hard coded particle number, so to speak. So we're going to temporarily put that simulation index into this variable called sin x, right? And now we kind of need to get the position data of that particle. So this all relates back to I, right? Remember, we're stepping through all the particles. So if you kind of think I is going to go 0, 1, 2, 3, 4, 5 until we reach the maximum particle count. And we're doing the same here. We're getting the simulation index for each of those particles. Then we're getting the vector data for that particle. Now, we're not going to be manipulating X and Y data here, right? We're only going to be doing Z, but I just put an example in here so you could see how you might manipulate X, Y, and Z data. We're interested in the Z data because we're going to play with the height, right? So here we're now putting the random generated height data from up here, we're putting it into the position Z data, right? Now we're not going to see that change until we actually update the position. So here we're using a tyFlow method, set position. So now this POS variable here is a 0.3 variable that holds the X, Y, and Z data. We've only adjusted the Z, so what we're saying here is set the position of our particle. The particle number is through the loop, and the position is from our random number generator, right? Then we're also going to, update the custom float data. So remember, we had a position start custom float and we had a position end custom float. Well, each one of these positions, we're going to transfer that height data back into the custom float. And that's all we're doing in this section of code. And that's how we get the initial or get a random start position. And because we created this custom method here, we will just be calling this. And that'll, all the stuff that's in here will happen automatically. Let's look at the next custom method that I've got. And we just scroll down here a little bit. And this is the custom method for the end position, right? It's a little bit shorter than the previous one. But if we look here, the custom method is called random end. That's what I've named it. Again, we're doing the random number generator thing. And again, we're going to step through each particle in the flow, and we're going to do what's in this box to each particle. And like before, we're getting a new random end position using the same global variable random minimum and maximum that we had at the top of the code, and we're going to transfer that data to our custom float, right? That's all this is doing, is we're generating a new random end position, and we're going to transfer that into our custom float in tyFlow called position end. And there's a final custom method down here, and its job is to move the end to the start. So in other words, the old end becomes the new start, right? So that's why I've called the method move end to start. And again, we're going to step through each particle in the event, and then we're essentially going to transfer the information that's in our custom float position end and move that data to the custom float position start. And like I said earlier, that means that the old end position becomes the new start position, so that there isn't a, if you just did a random start and you didn't use the old end, you would get a jerk every time, or because you would get a jump in all the particles. So say every 20 frames you would have a smooth animation leading up to the 20, but then when the position, if you didn't do what I'm doing here, the position would just randomly be a new position and you'd get a jerk every 20 frames. So that's why we're transferring the end position to be the new start position. And then when we look in the what happens on each step here, right? So this is the simulation step part of the tyFlow script operator, right? So this is going to happen every position step, and we only need to worry about this because this is actually only what we're using. And when we look here, so what I'm doing here is I'm testing for frame 0. Are we on frame 0? And basically on frame 0, I'm going to initialize all our particles. So that's all. So it's going to call those two custom methods that we just went through, and it's going to update the position start, position end, and actually initialize all the particles to have a position. And then on, if we're using frame skipping because every frame was too quick. So what I'm doing here is, if the frame number modulus is even divisible by our frame skip, right? And so this is a test here. This is a test to say if the frame number is evenly divisible by our frame skip, the result of that is 0, which would be evenly divisible. For example, when I said earlier 10 divided by 3 would leave a leftover, that would mean it's not even divisible. So if we want to do a frame skip of some kind, the resulting number from the division needs to be 0. So this is how we end up creating a frame skipping test. And when on every frame we're going to update the end to the start position and then get a new random end. So I'm hoping that you can see how that works. And when you think about it, apart from our three custom methods, this is all the code that we actually have written in the simulation step. So you can see how organizing the code and everything kind of makes it, and commenting makes it easier for you to understand what's going on. And also when you come back later to reuse some of this code, if you do comment it and understand it, you'll end up having lots of little reusable code snippets that you'll use over and over again. Like there's nothing to stop us later on going back up here and grabbing one of these random number methods and copy it. And don't forget, you know, you can save you can save script. So you can just save snippets of code. So when we look at our flow here, right, in the script we were updating these two variables, right? And because they're not actually used within tyFlow, as in the way you would normally use a custom property operator, because they're being updated via script, you know, the timing is just set to event entry for each one of these. Now, this one here is purely for color data. So every time we cycle through this flow, we also update the height position in another channel called position Z that we only reference here for the height data. And because we've set a height hard coded in script, we know what the minimum maximum is. Before, if you do this kind of custom properties, you go in and you enable this display data, you try to figure out how high your particle is moving, then you try to find that minimum maximum, and you put those values in here. Because we've hard coded them in script, right, we go back here to our script operator and we see here, you know, we've got 1 to 26. Now the actual number here is 25 because we're testing for if it's less than. So when I say if it's less than 26, that means 25, right? So you can see that now in this mapping operator here, I can just hard code these values because I already know what they're going to be, and that's why it's such a beautiful mechanical movement, right? You see the particles here stop at certain heights, all right? It's not random all over the place as far as the maximum height. And for the color ramping, we're just kind of using a typical gradient ramp here. I've got it all mapped to a multi sub object. Now this little bit here with the ramp and then the blue and the thing, that's just habit that I know from when you use the shell operator here. You can have a outer, inner and edge material ID. In other words, you know, side, top and bottom. And in this instance, I'm using the gradient ramp for all three so that we get nice coloring across each particle, each cube. And the black material here was, I just set up a background to be a black color for when you could see past the particles, rather than having whatever the max default background was. And in this instance, we're not using the blue and the yellow because we're using the gradient ramp for all sides. So that's the color portion of it, right? And for those that kind of want to know everything about my layout here, or my flow, right, if we just kind of step through it for those that kind of want to either grab screenshots or something of all the settings, so to speak, right, you know, it's fairly typical stuff here. And the timing here, you can pause the video if you want to get specific details. For most part, I think that kind of covers this tutorial. I think I'll leave it at this point for this one. Maybe we can do another one. And I hope you find some of the information in here helpful. And we'll see you on the next one.